Hello everyone, welcome back to another video. Today we're going to be discussing the instrument landing system, also known as the ILS approach. We're going to be talking through what actually is an ILS approach, how do you fly one, and then there's also going to be a video so you guys can see and practice yourselves. This is entertainment purposes only and for flight simulator use only, so this does not apply to the real world. So, what is an ILS? An ILS is an instrument landing system, which is a precision and 3D approach. It's a 3D approach because it has guidance in 3 dimensions, which means it has greater accuracy than a non-precision approach, which only has lateral guidance. Because it has greater accuracy, it has a lower minima than a non-precision approach. So, the guidance in 3 dimensions then. So it has lateral guidance in the form of a localiser, which shows your lateral deviation from the localiser. It has vertical guidance in the form of a glide slope, which shows your indication and deviation off the glide slope. It tends to be a 3-degree glide slope. That is your standard glide slope. It also has a distance guidance in the form of a DME, distance measuring equipment, and also it has marker beacons. Not all ILSs will have a DME, however 95% of them do. Generally the ILS has a system minima of 200 feet for a Cat 1 ILS. A Cat 1 ILS is the least accurate ILS but tends to be the most common. And this is generally used in worsened weather conditions, considering that a NDB approach usually has a minima of about 250 to 300 feet. So it's quite a difference in bad weather conditions. You can also get Cat 2 and Cat 3 ILSs, which are either 100 feet or less than 50 feet. However, these require special aircraft equipment, which a lot of general aviation aircraft won't have. So you can see a picture of the PFD here, showing you the differences on an ILS approach. So you might have seen these or you might not have. And you might have seen them in other aircraft such as an AE320, but generally it's all the same principle. So on the glide slope, which is on the right in the red box, you have your glide slope indication in the form of a green dot. This will move up or move down depending where we are in relation to the glide slope. And we always need to fly towards the dot. So if the dot goes up, then we are too low and we need to fly up. If the dot is too low, we're above the glide slope, so we need to fly down. In the orange box, we have the localiser. This appears the same as a VOR indication, it's just a lot more accurate than a VOR indication. The full scale deflection of a localiser is 2.5 degrees, so it's a lot more sensitive than a VOR. And then in the purple box we have our DME, distance measuring equipment, which remember is a slant range from the aircraft to the DME. So if we fly overhead a DME, it won't read 0. On a precision approach then, so we will be flying it like this. So once we are established on a localiser, we establish the localiser as any other approach. It's the same. So you can either get a radar vectored ILS or you can do a procedural ILS. On training, you'll most likely be doing procedural ILSs. So once we're established, we need to then establish on the descent. And we do that by intercepting the glide slope. So the glide slope, as I said, is in the form of that green dot. And when we're approaching the glide slope, we need to configure the aircraft. So in still wind conditions, when the green dot, the glide path, is 1 dot above the line, we're going to reduce our power to our descent profile. If we've got a strong headwind, we might want to reduce it when the dot is a bit lower. And if we've got a strong tailwind, we might want to reduce it a little bit earlier. Now, when the glide slope touches the line, we need to set our flaps on the approach. So that could be, depending on the aircraft, You need to know your own configurations, but we set the flaps at approach, and then we set our rate of descent. So it's the same as a non-precision approach where we check our ground speed, times it by 5, or we can check the chart, and then we set our rate of descent, which will maintain us down the approach path. When we intercept the glide slope, we want to check at the platform altitude that we are intercepting the correct glide slope, because there are two glide slopes. We have the normal glide slope, so let's say there is one at 3 degrees, and then there will be a false glide slope which will come out the top of the ILS, which if we intersect that, that could be a 6 degree or more glide slope, and we don't want to follow that. So we need to check our altitude to make sure we're on the true glide slope. Then if the RVR is below the requirements, then we will need to check the RVR as we get to 1,000 feet, also known as the approach span gate. However, if the RVR is already above the requirement, we do not have to do this check. At 100 feet plus our minimums, we're going to call out 100 to go. And then at minimums, we need to make a decision. If we have the runway in sight, we're going to call visual continue. Should we not have visual, we're going to go no visual, going around. Then we're going to initiate our go around procedure by applying full power, pitching up. Once we have our positive rate of climb, we're going to put our flaps up and advise ATC. If we're visual and we're continuing, then we need to do our landing flow. So we would want to check our gear down if we have gear and set our flaps at landing. So the precision approach maintenance. So now you know how to intersect the glide path. Now we're going to learn how to maintain the glide path. So we want to maintain a very high scan rate. Our eyes are going to be going very quickly because we're both looking at the localiser and the glide slope, and they're sensitive. So we want fast eyes, slow hands. We don't want to be making large corrections, otherwise our approach is going to be very unstable. We want to fly the attitude and reference the ILS. So we're setting our attitude and setting that rate of descent, and then we're going to reference the ILS to that. If an undesired trend develops, so that means if we're off our lateral deviation, off our speed, or off our glide slope, we need to make small attitude or small heading adjustments. So we only want to adjust the pitch by about 1 degree, and we only want to change the heading by maximum 5 degrees. When we're close, a change of 1 degree may work, but we're making very small adjustments to maintain the approach path. We're going to continue the instrument scan, so we're checking speed, glide slope, rate of descent, and our localiser deviation. Once we're back on the localiser and glide slope, we're going to adjust the attitude to maintain and set the power as we require. And as we mentioned before, it's the same principles of the VOR. So if the centre line is to the right, we are to the left. You need to fly to the right. If the CDI is to the left, we're to the right, so we need to fly to the left. And the same is with the glide slope. So now we're going to go on to the chart. So this is the NDB ILS DME approach for runway 19 at Oxford. Not all charts will have a NDB. It depends on the airport and what's coupled in. It might be a VOR ILS DME approach. But generally, the charts all look relatively similar. So we got our localiser DME, localiser frequency, 108.35. So the localiser, this is what we tune in to get the both the ILS and the DME readout. The final approach course. So this is the course we need to set on our CDI in order to maintain the localiser. The platform altitude is this box here, 1,800 feet. and the descent will begin at 4.7 nautical miles. Airport elevation 263 and the runway elevation is 258. It has our missed approach. So the reason we have an NDB ILS, the NDB is used for both the missed approach and the base turn. We have our MSA on our right, and we require a DME or a radar. So if we don't have a DME equipment on our aircraft, we will need Oxford radar to give us DME readouts. We have our speed restriction and the ILS DME reads 0 at runway 19. We have a couple of warnings around, so make sure we read these before when we brief the approach. We have our Morse identifier for the ILS DME frequency. We have our altitude readouts. So we don't actually need these because we're on an ILS. However, we would need these for a localiser DME, as that is a 2D non-precision approach. We have our profile here, so we need to be at 3,500 feet over the hold. Then once we're beacon outbound, we can descend to 1,800 feet. At 6.5 DME, we can turn inbound to the localiser to intercept it. 4.7, we start our descent for a 3-degree glide slope. We have our ground speed indications here, so if we're doing 100 knots ground speed, we need to do a rate of descent of 530 feet per minute. It shows our lighting requirements here, so this is the lighting Oxford has, so this can affect the RVR requirements, and then it has our missed approach here. Depending on your aircraft, depends on the category we require. So Cat A, it would be something like a PA28 or a DA40. So we could use 563. We always round up if we can't set 563, so we would set 570 in our aircraft. And then it's also got the required RVR. And then the so-called to land elements here. So that is the ILS approach. We're now going to go over to the simulator to show you how to actually fly one. Okay everyone, we're now in the air again. So we are currently in the hold over the Oscar X-ray at Oxford for the ILS approach runway 19. So we're tracking on the inbound leg to the hold, as you can see. As we get to 1 nautical mile from the approach fix, we would like to set up our next step. So we want to twist the course to set the outbound course, which is 358, and we're preparing for the event to turn. So we're coming about 0.7 now, so you can see the needle starts to flip. I'm just holding my heading as we're in the cone of confusion. So I'm twisting my heading to the outbound heading, still holding this heading and waiting for the needle to flip. And now the needle has flipped, I can turn. So I've twisted, I can turn, I can torque. So VATSky 01, beacon outbound, and timer we have started. So we now need to descend to 1,800 feet. So 1,800 feet set, T's and P's in the green, 1002 cross-checked, and start our descent. So now we're just we're pulling the tail round to set it on that outbound course of 358, and we're just going to maintain the heading down the approach path. So we want to try and maintain, so we want to get to 1,800 feet before we start our turn, just to reduce the workload as we eventually get there. So we got 1,000 to go. So we're still maintaining down now. So we're checking our distance. So we got 3.8. So we've still got a couple more miles to go. And we're now going to start thinking about doing our before landing checklist. So brakes released, undercarriage fixed, fuel balance sufficient for go around, landing light is on, T's and P's are in the green, hatches harnesses are secured. Now we're approaching 1 mile until we have to turn. So in 1 mile before we want to set our final approach course, which is 190 degrees. And we'll also want to set a command heading. So same with a non-precision approach, we want to set an intercept heading, which is about 30 or 40 degrees off our final approach track. So we're going to set about 150 degrees. So we're now 0.2 away, so 6.5, we've twisted, now we're turning. Don't need to time and no need to talk at the moment. So we're just maintaining the turn now, and we want to roll out and wait to intercept the localiser. So we're simply just going to maintain this heading until the localiser starts to move, and then we'll make a turn inbound. So the localiser is starting to move, so I'm going to bug my heading, just maintain this for now, and then as it starts to come about half scale deflection, I'm going to start my turn and adjust my turn rate for as quick as the localiser moves. You can see it's moved a little bit slower than I thought it would, but that's absolutely fine. So 1 dot above now, reducing the power to 30% and letting that speed come back to 90 knots. And we're just simply pitching up to maintain the altitude as well. And we're waiting for that dot to touch the line, which we have, so we're set flaps at approach, and then we're going to select our nose down for our rate of descent. So the ground speed is about 85 knots, so about a descent rate of about 450 will be suitable for this. So we're also going to do a quick check of the chart. So 5 miles, we should have been at 1800 feet, which we were. And we're simply just monitoring this down the approach now. So I'm going speed, glide slope, localiser. Speed, glide slope, rate of descent, localiser. And we're simply maintaining that all the way down the approach path. We don't have to worry about checking the altitude, as we have the vertical guidance. If this was just a localiser approach, we would have to check the it, but in this situation we don't. So it was 5 knots too fast, so but that is fine. We do have that headwind as well, so we're just adjusting to maintain. So we're pretty much on speed, we're on glide slope, trying to maintain that altitude. We've got the localiser coming through 1,000 feet. RVR's already above requirements, so we don't need to do the approach band check. However, 1,000 feet we are stable, so we can continue the approach for now. If we were unstable at this point, we would go around. So we're slightly right of track, so we're going to make a small adjustment to the left. As you can see, look how sensitive it will move. So, still on profile, 100 above, 100 above, still maintaining the glide point. We are approaching our minimums now, minimums, visual, continuing.
Minimums.
So flaps set at landing, runway is clear, clearance is received, approach stable, flaps landing. Now I let that speed come back now, looking for the numbers, and it's now a normal approach to land. Bit of a bumpy landing there, but then we're going to bring it to a complete stop on the runway. Usually you would vacate. So this is how you fly an ILS. If you do have any questions, please do pop it in the comments.